In this video, I'll be solving the third part of the first problem of UPSC Indian Forest Service 2025 Statistics Paper 1. So let x1, x2 and so on xn be random sample from uniform 0, theta, and let xn, which is maximum of x1, x2 and so on xn, and yn is 2 by n summation I is equals to 1 to n xi. So we need to show that xn is a consistent estimator of theta, and we also have to check like whether yn is consistent and unbiased for the parameter theta. So like first if we consider like xi, so xi is following like uniform 0, theta. So that means CDF of each xi is nothing but f of x, which is 0 when x is less than 0, and it is x by theta if 0 less than or equal to x less than or equal to theta, and 1 if x is greater than theta. So that means for 0 less than or equal to x less than or equal to theta, so we have this probability of x of n less than or equal to x is nothing but probability of x1 less than or equal to x, x2 less than or equal to x, and so on, probability of xn less than or equal to x. So that is probability of x1 less than or equal to x into probability of x2 less than or equal to x, and so on, xn less than or equal to x. So that is nothing but fx of x whole to the power of n, which is nothing but x by theta whole to the power of n for x belong to 0 to theta. So if I consider an epsilon greater than 0, so then probability of this xn minus theta greater than or equal to this epsilon is nothing but probability of xn less than or equal to theta minus epsilon plus probability of xn greater than or equal to theta plus epsilon. But we know that this quantity is nothing but 0. So that means this is nothing but probability of xn less than or equal to theta minus epsilon, and that is nothing but, we just found the density function, the CDF function, which is nothing but x by theta whole to the power of n. So that is nothing but theta minus epsilon by theta whole to the power of n. So that is probability of this xn less than or equal to theta minus epsilon, which is probability of mod of xn minus theta greater than or equal to epsilon is theta minus epsilon by theta whole to the power of n. And this tends to 0. We know that this tends to 0 as n tends to infinity, because theta minus epsilon by theta is in between this 0 to 1, will always lie in between 0 to 1. So that's why like it tends to 0 as n tends to infinity. So therefore this probability of mod of xn minus theta greater than or equal to epsilon tends to 0, that is xn tends to this theta in probability. Hence we can say xn is a consistent estimator of theta. Hence we have showed that it's a consistent estimator of theta. In fact, like we can also see that expectation of this x of n, or like nth order statistic, is nothing but n by n plus 1 theta. So that means like it is biased, but the bias tends to 0 as n tends to infinity, So that's about the first part. So we have shown that xn is a consistent estimator of theta. Now if we consider the second part, like we need to check that yn for consistency and unbiasedness for a parameter theta. So first, like we're having xi follows uniform 0, theta. So that means expectation of xi will be theta by 2, and variance of xi will be theta square by 12. So that means unbiasedness. In order to check for unbiasedness, expectation of yn is nothing but 2 by n summation I is equals to 1 to n expectation of xi, which is 2 by n into expectation of xi, which is theta by 2, which is theta. So that means we can see that yn is unbiased for theta. Now if we compute the variance of yn is nothing but 4 by n square summation I is equals to 1 to n variance of xi. So which is 4 by n square into, so n times each variance is theta square by 12, which is theta square by 3n. And we know that this theta square by 3n tends to 0 as n tends to infinity. So by Chebyshev's, again, like by Chebyshev's inequality, so we can note that for any epsilon greater than 0, So probability of mod of yn minus theta greater than or equal to epsilon is less than or equal to variance of yn divided by sigma square. So that is nothing but sigma square by theta square by 3n epsilon square, and this tends to 0 as n tends to infinity. So that's like we can say that this yn tends to theta in probability. So that means like yn is consistent but yn is not biased. So yeah, so yn is also biased, I think. Yeah, yn is unbiased and yn is also consistent. So like, yeah, so it is consistent, unbiased, and xn is also consistent. So that's it for this video. We'll meet in the next.